Welcome to our course Neural Network, and in this course we're going to study when we can say and identify that a certain perceptron or neural network has a bias. So first of all, what is a perceptron? I think it's always very important to go back to the basic so that we would be able to understand how perceptron, how a neural network really works. So basically, when we say perceptron, we refer to a set of inputs that is directly mapped to a certain output. So for example, we have here a certain input, which is X, and it is mapped to a certain output, which is Y. But this does not work as simple as this once because in between X1 and Y1, there is always what we call an intermediary. So when I say intermediary, I mean here to say that there is a layer between them. So layer. So for example, we have the layer in between x1 and y1 is w1. And when we say w1, it refers to a certain weight that is attached to a certain x1 in this case. So we have here x1 and w1 and y1. What do we mean when we see all of these things? So for a certain output, because y1 here is output, let's just say y, right? Y. Never mind the one here, so that we won't be confused with how all of these things really work. So we have x1, for example, then we have x2, x3, and so on and so forth. So until xd, okay? So when you see all of these things, x1, we refer to them as our feature variables. Okay, feature variables. So we mean to say that when there are feature variables, then we would be able to understand how a certain y comes out. So this is the output. So this is feature 1, feature 2, feature 3, and feature 4, and so on and so forth. So for each feature, there is always an attached W1, which is a certain weight. So we have here W1, it could be W2, which is attached to feature X2. Basically, this is the basic architecture of Perceptron. And in this case, maybe you would want to ask me, so how is this related to prediction? How is this related to classification in this case? We have here a certain value of y. All of these variables have a certain weight, and then when they are put together, they are mapped to a certain y, and this y can have a certain value. It can be 1, it can be -1, it can be somewhere between 1 and -1. So what we mean here to say is that there is a prediction value, which we can say that it's classified as being yes, it can be classified as being no, or in some cases when we say, for example, we're talking of credit card fraud, got me right here, credit card fraud, we would say that 1 is there is a perfect fraud, and -1 there is no fraud at all. Or so when we say 0, that's something that is very dubious in between them. So as it is closer to 1, there is a higher possibility of fraud in the credit card transaction. And the higher or the closer it is to -1, there is a greater possibility that there is no fraud involved in a certain credit card transaction. So in Perceptron, the magic actually does not work here. So what I mean by this is that there is no computation involved in x1, x2, w1, w2. So where does the magic lies? And the next question would be that where is the bias lie? Now let's proceed to this one, and we would be able to understand more of this bias and the computation when we discuss these things. So as what I have said, this one, x prime represents the different features that is involved in a certain case. And we have here w prime is a weight that is attached to a certain x that corresponds to a certain w. So for example, x1 is mapped to w1, x2 to w2, and so on and so forth. So here we need to take note of that the input layer does not perform any computation in its own right. So there is no computation in their own right. So what do we mean by this? What do we mean when we say that there is no computation that is performed in the input layer? So the linear function is this. So W prime times X prime, which is equal to when we say the summation of Wi and Xi, that is from I equal to 1 to D. So D here can be any number of transactions or the number of features and weight in this case. So bias. Let's go to bias. So when can there be bias in this case? We have said that X can have a certain value of weight. And if in some cases, we could see that the error in the computation can be illogical, or it's something that is not expected in a certain normal transaction, then what we're going to do is that we can adjust the weight. Say, for example, weight 1, which is equal to 1, can now be equal greater than 1, which can we say it can be, for example, equal to 2, or it depends on a certain case. Okay, so that is why in this case we can see and we can say that there is really bias. And so the final computation for our output node or for the linear function is this, the y hat, which represents the predicted value, which is equal to the sign. Then we have w prime times x prime, which is equal to sign of the summation from I equal to 1 to d of wj to xj. So what's the function of sign in this case? What does it do? It actually maps a real value to either +1 or -1, which is appropriate for a binary classification. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.